All right, so today we're going to concentrate on area, so our topic is area. We're not going to do any perimeter today. Well, you might have a problem that involves perimeter, and like one problem. And if we get to it, we get to it. If we don't, then you can ask about it tomorrow. These are notes for 11-1. If you're trying to compare this to your textbook, this unit of study, surface area and volume, corresponds to chapters 11 and 12 in your textbook. And they won't necessarily correspond to the same section number, so it is what it is. And then all you have to know today are those area formulas. But they all relate to this area formula right here. That's your important formula. Isn't a triangle half of a rectangle? Can't I put a diagonal in that rectangle and I get two triangles? So if I want the area of a triangle, I just find the area of its rectangle and take half. So that's where 1/2 base times height comes from. Base and height is the same as length and width. So if you look at a parallelogram is just a pushed over rectangle. So the fact that you have area equals base times height versus area equals length times width, it's the same thing. They don't mean anything different. Personally, I wouldn't memorize another formula for a square. Isn't a square just a rectangle? True or false? So why memorize area equals side squared when it's still length times width or base times height? I mean, so you don't have to memorize that one. We already know the area formula for a circle, so you're supposed to already have that memorized. This is the only hard formula out of all of them on the sheet, and this is your trapezoid. If you remember the definition of a trapezoid, there is only one set of parallel bases. The other set of sides are not parallel. So if it's a trapezoid, it has exactly one set of parallel sides. And those parallel sides are your base sub 1 and base sub 2. Doesn't matter which one is base sub 1 and which one's base sub 2. Height in all of these formulas is always perpendicular to a base. They're going to give you more information than you need. You're always looking for that height that's perpendicular to a base. So that tells you what your bases are, and then it tells you what your height is. We might have to use some prior knowledge to find those. We might have to use some algebra to get there. Just depends. So I'm going to kind of skip around on some of these, but I'm going to start with an easy one so you can see exactly what I want from all of you. No matter how good you are at memorizing, I still want the following things from you. So thing one, you're going to look at a problem like this, and this is a pretty simple one because what type of figure is this? A square. So you could either use the square formula, area equals side squared, or you could just use the fact that you know it's rectangle, area equals length times width. I don't care which. Or base times height. I don't care which. You can use any three of those formulas and you're going to get to the same place. I have to see the formula. Murray's law is the more times you write down the formula, the more likely you are to what? Memorize it. That's how you're going to memorize it. Those of you who have trouble with it. Those of you who don't have trouble memorizing, you're like, I don't need to write down the formula. Yes, you do. I want to see the formula. You are not allowed to do scratch work. I want to see the formula. This is all equation driven and algebra driven. So for right now, there's not a lot of algebra here because I'm going to use substitution parentheses. The 8.5 is, I don't know, this is, oh, I guess I'm using base and height, so hang on. So this would be my length. Oops. This would be my length and this would be my width, right? Or my base and height, whichever you want. So I want to see you plugging into the formula. Notice I haven't picked up my calculator yet. I want you to put in your units of measure into the formula because that's going to help you get your units of measure for your answer. No matter who you are, no matter what type of student you are, good, bad, whatever, I want to see those two things. The formula, plugging into the formula. Now you can pick up your calculator and actually do calculations. So for this one, we're going to take 8.5 times 8.5. And then if they don't say word around, and on the directions here, it doesn't say word around, does it? So you're going to give the extended answer. So this one is equal to 72.25. What's feet times feet? feet squared. So there's no reason not to get the proper units of measure in your answer if you're using algebra to get there. So those are the three things I need. Formula, substitute into the formula, use your algebra to solve. Those three things I want to see every single problem. All right. I'm going to mention number 2 only because it's a triangle, and for whatever reason we have issues with triangles. So you have a couple of ways you could write the triangle formula. You could say area equals 1/2 base times height, or some of you learned it this way. Area equals base times height divided by 2. Agreed? Does it matter which one you use? Nope. I don't care which one you use, but you have to be careful with the first one. And so let's go ahead and plug and chug. Look at our picture here. What does the 15 represent? Is it base or height? It's your base. And so the 23 is height, and I know it's height because it is a perpendicular line to that base. So I know it's my height. Sometimes they don't give it to you, you have to find it. And so then we're going to plug. So if I use the first formula, my base is 15 meters. My height is 21.3 meters. What do you think the error is that kids do? You're right. The biggest error is that kids distribute this 1/2 into both of these. They'll take half of the 15 and half of the 21.3. There's no addition or subtraction signs here. You don't want to do that. So if I were you, what would you do first? The smart thing would be to multiply your base and your height together first and then take half the answer. So what I would prefer to see from you is, instead of doing it all on your calculator at once, I want to see what is 15 times 21, because if you 21.3, because if you make an error, I don't know where your error was if you just do it all on your calculator and then spit out an answer on paper. So remember, your calculator is your tool. It doesn't do all the work for you. So you're going to put in here what you got. 319.5 meters times meters is meters squared. And now I can take half of that. How do I take half of it in my calculator? How do I take half in the calculator? Divide by 2. And so we end up with area equaling 159.75. I want the full answer, meters squared, because they mention nothing about rounding. So if it's more than one step to get to the answer, I want to see the interim work. Notice how there's no scratch work up there. If you turn in homework to me with scratch work, I will mark it half off. I want to see the formula, substitute in, and the answer. So don't get mad at me when I mark it half off, because some of you are going to get mad at me. Okay. Let's just talk about a couple of these. We're not going to do all of them. What figure is this? Parallelogram. So your formula, and we're just going to write the formulas, would be base times height. And they've given you just enough information to figure that out, right? So that one's not too tough. This one should be fairly simple. What is it? A circle. Your area formula for a circle is pi r squared. We've done a lot of those, haven't we? Well, what did they give you here? What's the 26 diameter? What do I need in my formula? Radius. So our radius is 13 yards. So we would plug that in there. So let's just remind you a little bit about the answers to circles. So if I were to plug that in, I can get an exact answer or an approximate answer. So I'm going to put in my 13 yards and square it. What should I do first? Square the 13. If I want the exact answer, this is how it's going to look. 13 squared is 169. The pi follows the number, and then yards squared is yards squared. So this would be my exact answer. Get in the habit of giving me both when it comes to circles. Or if I want to round to the nearest tenth or hundredth, we're going to take the 169 and multiply it by the full pi button on your calculator. And so if I round to the nearest tenth, I now have squiggly equal signs, and I have 530 point, and I have 0.929. 0.929. If I want to round to the nearest tenth, what do I put? 0.929. Nearest tenth. 0.929. Just 0.9. And then yards squared. And so this is my estimated answer. How do you know which one to give? Well, if you're not sure, always give both. Unless the direction said give answer in terms of pi or give exact answer, then if you give me both, I'm going to mark you off because I don't know that you know which is which. So just make sure you're reading the directions. If the directions don't mention anything about rounding or exact answer, then you can give both and you'll be safe. So any issues, problems, or concerns with that? Yes?
So if it doesn't say round to
The nearest tenth.
whatever, just round to the nearest tenth.
I would give both.
I mean, like, if they want, like,
Oh, if they don't mention rounding, notice I've been giving exact answers. Okay, if the answer turns out to be a really, really long decimal for whatever reason, then I would say round to the nearest hundredth, 2 decimal places, if there's no mention of rounding. Okay, that's just rule of thumb. All right, 5 is an interesting one. So discussing your table groups, what shape number 5 is, what formula you're going to use, and what pieces in that picture pertain to the formula. So you got 10 seconds. All right, so stop. Freeze. Trevor, what did you guys decide this was? How did you decide it's a trapezoid? It's a funny looking trapezoid, isn't it? He's correct. Aren't there 2 parallel sides here? And 2 unparalleled sides. That's a definition of a trapezoid. It looks weird because these 2 sides are tilted in odd directions, right? But you've got 2 parallel sides here. Isn't this a perpendicular line to a side? That means 27 is a base. What does that make 16? So this is going to be base sub 1. The 19, the parallel side, is going to be base sub 2, or vice versa, it doesn't matter. And because the 16 is perpendicular to those 2, it is the height. My formula for area of a trapezoid is 1/2 the sum of the bases times the height. That means that I don't need the 16.5 or the 21 for this problem. What would I need them for if I were doing what? What would I use those to find? What? Perimeter. But they didn't ask us for that, so I don't need them. So you're going to have to sift through some extra information. So then we're going to plug in using substitution parentheses. So B sub 1 is 27 centimeters. Make sure you're using those units of measure. Plus 19 centimeters. And then the height is 16 centimeters. Order of operations say we should do what first? Yeah, we're going to do that first. I would not distribute the 1/2 if I were you. We're going to avoid that if at all possible. So what is 27 and 19? So we get 36 centimeters. Centimeters plus centimeters is still centimeters. It's not squared. Times 16 centimeters. Now, oh yeah, sorry. 46. You could take half of 46, or you could take half of 16, but you can't take half of both of them. So again, I would emphasize that you're going to multiply those 2 together first. So you've got 46 times 16, and so our area is going to be half of 736 Centimeters times centimeters is centimeters squared. And then finally you can divide by 2 to take half. And so our final area is 368 centimeters squared. If you skipped all of that work and you made a mistake somewhere, I have no idea where you made the mistake. None. If you went from here to here and skipped this, I have no idea where your mistake is. So you get very little credit compared to somebody who showed the work. I could just say, oh, they made this a 5 instead of a 6 for whatever reason, but they understood everything else. If you don't show that work, I can't give partial credit. Okay? So it's in your benefit. Take the time, kill a tree a little bit, just a little bit. You can replant it. All right, so then look at 6 is pretty simple, wouldn't you agree? Okay, so let's skip 6. What kind of thing is 8? Parallelogram. What's the area for a parallelogram? Okay, so we're not going to fully do this one. We're just going to talk about it. Base times height. So if I were you, I would always identify your height, which helps you identify your base, because you've got 4 different things on here that they've given you. Which out of the 4 is your height? Yep, so the 16 is your height because it is perpendicular to a side. The side that it is perpendicular to is going to be what? What's this going to be? The height is always perpendicular to the what? The base. So there you have your base and your height. Can't you just plug it in there and go? Okay, so we're not going to finish that one. Number 7 is a weird triangle. It's an obtuse triangle. The only reason why I'm pointing that out is because your area formula for that triangle, I'm just used to using this one. You can use the other one if you want to. It's 1/2 base times height. I have to identify my base and my height. They've given you 3 things on here. What's your height? This is a perpendicular, these 2 lines are perpendicular, agreed? This is the vertical one. This is going to be your height. It is perpendicular to this one. That's going to be your base. The 37.2 is garbage. It's extra information. So now you would plug that in and finish it. Agreed? Okay. Then I want you to talk in your table group about number 9. What are you going to do about 9? So discuss amongst yourselves. You're going to have to create your own formula. All right, so freeze. So Serena, you want to explain what y'all were talking about? Yeah, you can do it. So Serena, you're going to create your own formula, right?
Yeah. So you solve for a circle like plugging 17.
Okay, well hang on. What's the area formula for a circle? Because we have to come up with a formula. Okay, so there's the area formula for a circle. Do we have a circle up here? How much of a circle? Half. So you could either do 1/2 here, right? Or I kind of prefer, instead of writing it that way, I would actually prefer to just divide by 2. Either way, it doesn't matter, right? But you got to create that own formula yourself. And then you can plug and chug into that formula, right? What is the 17? Is it diameter or is it radius? It's halfway across, so it's just radius, right? So we're going to put in pi, and then our radius is 17 feet, and then it's all divided by 2. So what should you do first? 17 squared, and we're going to try to get our exact answer first to see what it looks like, because it is dealing with a circle. So we've got area equals 17 squared is 289. The pi follows the number. Feet squared is feet squared. And all of this is divisible by 2. I personally would leave this as my exact answer because 289 is not divisible by 2. Don't give me the decimal. If it were divisible by 2, you would take this number and divide it by 2. But it's not, so we're going to leave it. That's our exact answer. Our estimated answer, we're going to take 289 times pi and then divide by 2. Now if I were to round to the nearest tenth, let me give you the long decimal on this one. It's 453.960. And then it's feet squared. Well, if I want to round, I could, okay, that's to 3 decimal places. But if I wanted to round to the hundredths place, what would it be? 453.96. What if I wanted to round to the 10th? Yeah, because of this 9, it's going to bump that 3 up to a 4. It'd be just 454.0. So you have to be careful with that one. So I'm going to round to the hundredths. So we get approximately 453.96 feet squared. So here are my 2 answers. This is my exact, and that's my estimated. Then before we get to the harder problems in your table group, I want you to do number 10. So discuss what is it, what's the formula, what parts of that picture relate to that formula, and then find the answer, the full answer. Look for your height. Remember what your height looks like. So what kind of figure is this? What kind of figure is this? It's a trapezoid. You need base sub 1, base sub 2, and height in the trapezoid. What are your bases? The 2 parallel sides of the 7 and the 13. Right? Is there a perpendicular measurement to that? What is it? Do you see how 5 is perpendicular to those 2 sides, 7 and 13? Don't make this any harder than you have to. I mean, some of you will try to turn this into a rectangle and then this into a triangle and then try to add those together. There's no need to. This is a trapezoid that's turned on its side. It is not sitting on one of its bases, and that's okay. But you want to identify the parts. There's that perpendicular piece to a side, so that means that this is a base, and that has to be the height. The height is always the distance between the 2 bases. So if you trace from base to base, you're tracing that height. And so this is what that looks like plugged into the formula. Now go ahead and do the algebra to finish it up. So I have 1/2 of 20 millimeters times 5 millimeters. 20 times 5 is 100 millimeters squared. And then half means area is equal to 50 millimeters squared. So they like to turn that kind of upside down on you on purpose. All right, so any issues, problems, or concerns with just basic area formulas? All right, let's look at something a little bit harder. Flip the page. You're like, oh, okay, this looks like a basic formula, right? Just what kind of figure is this? A right triangle. So if I'm going to find the area of a triangle, isn't that area equals 1/2 base times height? Where's my base? Where's my base? 7 feet. Where's my height? Right there. It's missing. The 18.2 is not your height. It's the hypotenuse. The height is always perpendicular to a side, right? Well, I need that height. How am I going to find it? Pythagorean Theorem. Very good. So this one involves prior knowledge. So remember, your legs are always a squared and b squared? Well, a and b. So I'm going to take my first leg, which is 7 feet, and I'm going to square it. I'm going to add to that the h squared, and then the hypotenuse is your 18.2 feet, and we're going to square that. So 7 feet squared is 49 feet squared plus h squared equals, and then on your calculator, 18.2 squared is 331.24 feet squared. How are you going to get h squared by itself? How are you going to get that by itself? Subtract the 49. So you get h squared is equal to 282.24 feet squared. How do you solve for h? Take the square root of both sides. It's in your calculator, hit the square root button, and you get a lovely h is equal to 16.8. And then what is the square root of feet squared? Feet. Now you have everything you need to find the area of that triangle. So now I've got area equals 1/2 times, my base always was 7 feet, but my height now is the 16.8 feet. And now it's just what we were doing on the other side. So 16.8 times 7 is half of 117.6. Feet times feet is feet squared. And then take half of that. So your final area is 58.8 feet squared. So you might have to have a couple of steps to get there. Bless you. So there's our prior knowledge. Don't forget about that. All right, number 12, a little bit more hairy. What kind of figure is 12? It's a trapezoid. Can I move this? Anybody upset if I move this? Okay. So as we look at 12, it's a trapezoid. And I'm finding the area of it, right? So here's our formula. So I need 2 bases and a height. Do I have my 2 bases? What are they? Okay, so this is, I don't know, base sub 1, and this is base sub 2, because those are the parallel sides. Agreed? Well, my height should be here, and it's not listed, right? This is my height. I got to be able to find it. Okay, so here's the deal. Notice a couple of things. This right here is 10, and this right here is 10. So this is an isosceles trapezoid, which is handy. Doesn't this create right here a right triangle? If I can find 2 of the 3 sides, I can find this third side using Pythagorean Theorem like we just did. Agreed? But I have to figure out what this piece is. I know the whole distance is 19, right? I'm going to put in another height right here. So I have 2 identical triangles there. These heights are both the same. This creates a rectangle in here. What's the dimensions of this rectangle? Well, sort of. Okay, what's this distance? 7. Doesn't that mean this distance here is 7? Okay, so this distance here is 7 centimeters. But the whole distance, stay with me, the whole distance from here to here is 19. If this part is 7, what's left over for this part and this part? The whole distance is 19. This part is 7. What's left over to be split here? 12. Because these are identical triangles, doesn't this get split evenly? What's 12 divided by 2? 6. So this becomes 6 centimeters, and this becomes 6 centimeters. If you add from end to end, 6 plus 7 is 13. 13 plus 6 is 19. Doesn't that give you 19 all the way across? Now don't I have two sides to this right triangle, and I can use Pythagorean theorem to find that height. You're going to want to star this problem because this is a tougher problem. So that's one you're going to want to study. So let's walk through it. So step 1, let's use Pythagorean theorem to find our height. So my legs are what? On this triangle, what are my legs? What are the legs? 6 and H. You got to talk to me. 6 and H. Aren't those my legs? So I'm going to take 6 squared, 6 centimeters squared, plus H squared equals, our hypotenuse is 10 centimeters squared. 6 squared is 36 centimeters squared, plus H squared. 10 centimeters squared is 100 centimeters squared. Solve for H squared. You should be writing this down, not waiting for me to do it for you. You did? All right, so we've got H squared is equal to 64 centimeters squared. We subtracted from both sides, right? What are you doing? Sit up. We don't lay on our desk. It is not nap time. You guys had a whole 3-day weekend. You should be well caught up on your sleep. All right, so then take the square root of both sides, and we get a height is equal to 8 centimeters. Square root of centimeter squared is centimeters. Did anybody see a shortcut to that? Anybody see a shortcut to that? A Pythagorean triple. If you notice, both of these are divisible by 2. If you divide them by 2, you got 3 and 5. Isn't there a Pythagorean triple that does 3, 4, 5? Right? And instead of this being 4, because both of those were multiplied by 2, you'd have to multiply 4 by 2 to get 8. So you could have done a shortcut with your Pythagorean triple, but most of you won't recognize that. Now that I know my height, and I have my two bases, so my height is 8 centimeters. Now plug and chug into that formula, please. Step 2. Use your area formula. Quit talking and work, please. So once we get that height, it's just doing what we did on the front side. So you get 104 centimeters squared. Okay, so let's look at a couple of more challenging problems. So then we enter a section that looks like word problems. And this is where your algebra skills come into play. So look at number 13. They have given you the fact that you've got a triangle. So the minute I see the word triangle, I'm going to go to area equals 1/2 base times height. Why that area formula? Because they gave me area was 45.5 centimeters squared. So area of a triangle, I'm going to use that formula. Then they give you some additional information. They give you the base measures 14. You're finding the height. So you're going to plug in what you know and solve for the unknown. If I see scratch work, you don't get credit for the work, just the answer. So we're going to plug in what we know. We know the area is 45.5 centimeters squared, put in your units of measure, equals 1/2 times the base they gave you is 14 centimeters, and then h we don't know. So in this case, can I take half of 14 nicely? Yes. If you couldn't, let's say that this was 15, if you couldn't, I would multiply both sides by 2. Why 2? Why 2? Don't go ahead of me, I'm asking a question. Why would I multiply by 2? To get rid of that 1/2. But because I can take half of 14, I'm going to do so. So 45, oh, that's terrible looking. So 45.5 centimeters squared. Half of 14 is 7 centimeters times that height. How are you going to solve for the height? What's happening between 7 and the height? How are you going to solve? Yeah, you're going to divide because currently they're being multiplied. So we're going to divide by 7 centimeters. And so we get height is equal to, this centimeter cancels with one of those centimeters, and you're going to take 45.5 and divide it by 7. So you get a height that is equal to 6.5 centimeters. So for several of you, that's going to be a more challenging problem to do. Look at, let's going to skip 14. Let's look at 15. The trapezoid tends to be a little bit touchier. A trapezoid has base measures of 23 and 29 and an area of 390. Well, that one's not so bad. I'd rather do this one. Let's look at 16. It's another trapezoid. They give you the area, so we have a trapezoid, and they give you the area, right? So let's start out with that formula. Area equals 1/2. Stop talking and listen with your brain. It's not about socializing. You're disturbing others around you. No. I don't know who it was, but you're disturbing me. All right, so they've given us the area, so I'm going to replace area with 58 squared feet equals 1/2. Do you have any of your bases? We just have one base, right? One base measuring 12 feet. We don't have the other base, so we're going to put, it doesn't matter which one you put it in for. So I'm going to put 12 feet in for the first one, plus b sub 2. And then the height they gave you was 4 feet. This is the hard, out of all the area problems that they give you, this is the hardest one to solve out of all of them, is to solve for one of the missing bases in a trapezoid. So here's my suggestion. I would not suggest distributing the 1/2. Because some of you are just going to take half of 12 and you're going to forget that if you took half of 12, you have to take half of b sub 2. I personally wouldn't do that. Now you could take half of the 4, but most of you are going to mess that up. So my suggestion would be get rid of the half altogether. How are you going to get rid of the half? Yeah, we're going to multiply both sides by 2 over 1 or just 2 to get rid of that fraction, that reciprocal. So we end up with 116 feet squared equals, these cancel, so you get 12 feet plus b sub 2 times 4 feet. Now we're trying to get b sub 2 out of jail, essentially. It's in those parentheses. What can you do with a 4? You could distribute it. That's more work. Isn't the 4 being multiplied to this? Couldn't we just divide? I would suggest that you divide by the 4 feet. That's the least amount of work, and I know that you all are interested in the least amount of work. So 4 feet cancels on the right. One of these feet cancels with one of these feet up here, and you have 116 divided by 4 is 29. So we get 29 feet is equal to, look what we're left with here, 12 feet plus b sub 2. How easy is that to solve now? What do you do to solve there? Subtract 12. So b sub 2 is equal to 17 feet. So I would star this problem. This is going to give you some difficulties. That's one you want to study. Okay. All right, so we've done questions like 17 before, so I'm going to skip that one. And then this one is the only one that's different. It says, find the perimeter of a square with an area of 361 square feet. How are you going to do that one? What's the formula for a square? Okay, so you could use a couple of formulas. You could use area equals, well, we don't want the perimeter because they gave us area, right? Didn't they give us area was 361 square feet? They give you area, you want to start with the area formula first, not the perimeter. Okay, so you've got two area formulas you could work with. They gave you the area formula for a square was side squared, right? I told you didn't have to memorize that. What type of figure is a square? A rectangle. So you can use area equals base times height or area equals length times width. You could use that, okay? Just as long as you realize that a square has equal sides. So then plug in what you know. I know that my area is 361 square feet. How am I going to find the side length of this square? How do you solve for s? Take the square root of both sides. And so s is not a perfect square, so 361, take the square root, oh, yes it is. My bad. So we get 19 feet. Does that answer the question? No. So this is step one. We want the perimeter of the square, correct? So if I drew a picture, you could either memorize the formula, right, or not. What's perimeter? Add up all the sides, right? So you could just add up all the sides. How many sides have 19? 4. Or you could know your perimeter is 4s. It's up to you. So my side is 19 feet. And so 19 times 4 is 76. So perimeter is equal to 76, and it's just feet. It's not feet squared. We didn't multiply feet to another foot. Okay, so that's that one where they're just throwing in perimeter there out of the blue. Then the last problem is the one that you're going to suffer a little bit with because it's your full application. There's a lot of parts to this problem. And you have one like this on your homework. So the question says, Mr. Peyton would like to paint his deck. The dimensions of the deck are shown below. If 1 can of paint, and this is important, 1 can of paint covers 72 square feet, how many cans will he need to purchase for 2, that's important, coats of paint? What do I need to know first? Area of the deck, right? So what type of figure is this? Trapezoid. So area is equal to 1/2 b sub 1 plus b sub 2 times h. What are my bases? 14 and the 24. What's my height? What is, trace the distance from base to base. Trace the distance from base to base. There's your height. What is it? 16. It's also perpendicular to them. So there's our height. So then we're just going to do what we did on the front, plug and chug. Again, I don't want to see scratch work. So we have found the area of our deck is 313.5 square feet. Okay, so I'm going to Home Depot. I know the area of my deck. What do I do with that? I gotta buy paint. How much paint, right? So if the area of my deck is 313.5 feet squared, and 1 can of paint covers 72 square feet, how do I figure out how many cans of paint will cover my deck? You're going to divide, right? So each can of paint covers 72 square feet, so I'm going to see how many 72 square feet are in the area of my deck. My feet squared are going to cancel. Then 313.5 divided by 72 is not going to give me a nice perfect answer. It's going to give me about 4.354. And this is cans. That's to cover my deck once. Ding, 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 ding. How many times do I want to cover my deck? Twice. So we have to then multiply this by 2 coats. So times 2 is now approximately 8.708 cans. Can I go to Home Depot and buy 0.708 cans? No. So how many cans? 9. So therefore, ... you will need 9 cans of paint. So there are 2 clinchers in here. Number 1, you had to find the area of your deck. Don't pack up, I'm talking. Number 2, you had to figure out by division how many cans of paint would go in there, and then you had to remember, because it's easy to forget, that you need 2 coats.